This is the energy diagram in the hydrogen atom. This represents the nucleus of the atom. This is the very first orbit for the electrons, second, third, and so on. Now, this diagram shows us how much energy an electron is required to have to go from the ground state to the second, which means 122 nanometer photon will move the electron from the first to the second orbit. Here, if the electron happens to be in the second orbit, it requires a photon with the wavelength of 656 nanometer to go from the second to the third orbit. When the electrons descend and they come down from a higher orbit to a lower orbit, then they will give away the same photon. So if an electron is in the third orbit and it comes down to the second orbit, it gives away a photon with a wavelength of 656 nanometer photon. In the hydrogen atom, all the transitions, that means moving from one orbit to another, that are visible, so we can see the light, so we can see the photons happen between the second and third, second and fourth, second and fifth, second and sixth, and so on. This is called the Balmer series of hydrogen atom. So if the electron absorbs a 656 nanometer photon, it goes from the second to the third orbit of the hydrogen atom. If it receives a 486 nanometer photon, it goes from the second to the fourth orbit of the hydrogen atom. If it absorbs a 434 nanometer photon, it goes from the second to the fifth orbit of the hydrogen atom. If it gets a 410 nanometer photon, it goes from the second to the sixth orbit of the hydrogen atom. And also, it will emit the same photons when it comes down from the sixth to the second. When it comes down from the fifth to the second, it gives us a 434 nanometer photon. When it comes down from the fourth to the second, a 486 nanometer photon. From the third to the second, a 656 nanometer photon. This is a beautiful red photon.